The next predictive model we'll cover are called decision trees. Now, what are decision trees? Decision trees are models which make predictions using a flowchart-like structure or logic. It is very useful for breaking down a decision in detail. For instance, the decision tree displayed on the slide is a decision tree to determine whether or not to buy a phone. In the context of data analytics, each split or branch is a decision based off information provided by a single variable. Now, decision trees are commonly used in medicine. They can be both simple and complex. The one on the left is a simple decision tree for determining whether a patient should stay home or be sent to the hospital based on if they have difficulty breathing or are bleeding. The decision tree on the right illustrates a complex tree for helping a medical provider determine if a patient's arteries are more or less than 50% occluded or narrowed. In the past, decision trees were manually created by people. However, in machine learning, decision trees are automatically created using past data. Computers can quickly create incredibly complex trees in seconds. Unlike logistic regression, decision trees are more flexible in their predictions. They can predict both numerical values, which are called regression trees, and predictions that only have a discrete number of categories, which are called classification trees. This module will be focused exclusively on classification trees. Let's revisit the simple decision tree we saw earlier about whether to send a patient home or to the hospital and recap. As we mentioned, a decision tree can be classification or a regression tree. In this case, this is a classification tree because there are only two possible predictions or outcomes. These are stay at home or send a patient to the hospital. In addition, each branch or split is based on a single variable. For instance, the first split is whether a patient has difficulty breathing. This would be its own variable in a data set, and this variable will tell us whether a specific patient was having difficulty breathing or not. Now, decision trees have many advantages. Once again, they are relatively simple compared to other algorithms. In addition, they are both intuitive and easy to explain. This is because you can visualize each decision tree and see how a computer created its tree or branches. This makes it easier to understand. However, there are several disadvantages. First, creating a viable tree can be resource intensive and a slow process for a computer. In addition, computers can create hugely complex trees. While you may be able to understand a tree like this with time, unnecessarily complex trees are not very good for general use. In addition, small changes in your data can lead to huge and inexplicable differences in how a computer constructs its trees. This may hurt how applicable your tree is for general situations or predictions.